In this video, we'll be running the Think Shadow example from the Photohub device SDK for Windows. I highly recommend you start with the simple and revertible examples. You can check my previous videos for guidelines on how to do it. The Think Shadow example demonstrates real-world firmware over-the-air update procedure using the Amazon Web Service IoT Think Shadow service. The Think Shadow is used to trigger firmware over-the-air updates on the device it represents through the cloud. The prerequisites and tools to run the Think Shadow example are similar to those in the simple and revertible examples. Make sure you have all the requirements on your machine before running the example. If you are new to Amazon Web Services IoT in general or the Amazon Web Service IoT Think Shadow service, you can find relevant introductory as well as detailed technical information on the Photohub device SDK page. If you have never used AWS before, you must create a new AWS account first. Log into the AWS IoT console and then set up an AWS IoT Think for your board. To do so, you first need to create an AWS Iet Policy. This authorizes your board to exchange messages with AWS IoT. In the left menu, choose Secure, select Policies, and then create a policy. On the Create a Policy page, in the Name field, enter a name for the policy. Don't use personally identifiable information in your policy names. In the Action field, grant the Connect, Receive, Publish, and Subscribe permissions. These are the actions that the device will need permission to perform when it runs the example. In the Resource ARN field, enter the wild character. This selects any client or device. For higher security, you should restrict which clients or devices can connect and publish messages by specifying a client Amazon resource name instead of the wild character. Choose the Allow checkbox. These values allow all clients that have this policy attached to their certificate to perform the actions listed in the Action field. After you have entered the information for your policy, choose Create. You then need to create the AWS IoT Think itself along with an X509 board certificate that is used to authenticate your board to the AWS IoT. A Think object represents a specific device or logical entity. To create a Think in the AWS IoT console, choose Manage, click on Things, and then on Create Things. For Think name, enter a name for your Think and click on Next. Select Auto-Generate New Certificate and then attach the policy you created previously. Click on the Create Think button, download each of the certificate and key files, and save them for later. You'll need to install these files on your device. Choose Done. Make sure you delete the initially created and named classic shadow of your AWS IoT Think. Under Manage, locate the Think that you've just created and delete the Think shadow under Device Shadows tab. You then need to create a Photohub product and download the Photohub device SDK for Windows. This was extensively covered in my previous videos. Now you need to prepare initial firmware version. Open the Think Shadow example folder in Visual Studio Code. Open the Demo Product Info header file in the Demo Product folder and initialize the Demo Product ID and the Demo Product Name constants with the ID and the name of the previously created Photohub product. In order to retrieve the ID of the product, go to the Product Details view on Photohub, click on Settings and then on the Expand button under General. Copy the ID into the clipboard and then initialize the constant accordingly. Update the Demo Product Name constant with the name of your created product as displayed in the product settings. Leave the Demo Product firmware version as is for now. In case you have selected anything else than SHA-256 as the binary checksum algorithm for your Photohub product, or opted for using a signature instead, you must also adjust the Demo Product Firmware Update Verification Algorithm constant accordingly. Open the AWS IoT Think Shadow Configuration C file in the Product folder and initialize the hostname endpoint.hostname and the AWS IoT conparams.thinkName struct variable fields. They should contain your AWS account's device data endpoint and the name of the previously created AWS IoT Thinks respectively. To retrieve the data device endpoint, go to AWS IoT Console and then to Setting. The name of the created IoT Think is available under Manage and Things menu. Open the certificate and private key files included in the ThinkShadow example. Replace other content with that from the certificate and private key files which you have created and downloaded during the setup of the Aws Iet Think for your board. Open the integrated terminal and build the example by invoking the make command. You can find the resultant firmware program, the executable Windows file, in the bin folder. Its name equals the name of the Photohub product configured in the demo product header file without spaces. Now you need to create and upload a new firmware version to Photohub. Go back to the demo product info header file in the demo product folder and bump the demo product firmware version constant. Rebuild the example using make update equals yes this time and locate the resulting new firmware using the Explorer view just as you did earlier. Its name is the name of the Photohub product configured in the demo product info header file without spaces followed by an update suffix. Copy its path to the clipboard and upload the resulting new program as firmware version 1.1 to your Photohub product as explained in my previous video. Go back to the Visual Studio Code and launch the initial firmware version by invoking the executable firmware program according to your Photohub product name. The firmware program prints a banner including the product name and the initial firmware version into the terminal output and connects to its Aws Iet ThinkShadow. Now you're ready to perform a cloud-triggered firmware over-the-air update. You can do so either interactively through the Amazon Web Service IoT console or programmatically by using the AWS CLI. We'll do it interactively. Go back to the Aws Iet console and revisit the unnamed classic shadow of your Aws Iet Think. Open the shadow state document for editing. Add a desired object with a new version attribute to indicate the new firmware version your board should be updated to, and a verification data attribute with the checksum or signature of your Photohub product. These can be retrieved from the details view of your Photohub product. Save the modified shadow state document by pushing update. This will trigger the firmware over-the-air update procedure. Upon successful completion, the initial firmware program exits and the new firmware version downloaded from Photohub is started automatically. The built-in self-test is executed, and in case it succeeds, the new firmware version is confirmed and stays in place. You can see that in the terminal output of the firmware program, it should show a banner with the product name and the new firmware version, or by inspecting the shadow state document in the Aws Iet console. It should reflect the new firmware version as the currently running version and include an update status attribute indicating the successful completion of the firmware over-the-air update. Congratulations! You've successfully run the Aws Iet Think shadow-driven photo update example.